Alright, so this is a screencast for average power, and our average power equals energy transferred over time taken. And here's an example with average power equals the energy transferred, which is 0.5 joules over 10 seconds, which is our time taken, which will give us 0.05 watts. And we have to convert watts to horsepower, so we get 6.7 times 10 to the negative 5 horsepower, or 0.00. Oh, no, it's another example.
Okay, so this is just to round it off of that, and this is just the example we did in class. But for our particular mousetrap, if you look at our video, okay, first of all, we're just looking at average. We know average power is, we have this formula: energy transferred over time taken. So if you watch this, it looks like roughly about 2 seconds. It goes off at about, yeah, it goes for about 2 seconds. And I'm just talking about the movement of the car, because that's what we're looking at here. And then, so after you look at 2 seconds, then you want to look at how much energy is transferred, and that would probably be our elastic energy right here. So we have 0.57, 53, 64, 6257. So, okay, so I was kind of, okay, yeah, it is elastic energy because I was just thinking of the flow diagram, and that's the work you're putting in. So that is the energy. That is the energy transferred. It's that number, and then divided by the 2 seconds we got. So I did that, and I got about 0.28768, and the units here are watts, because whenever you have joules divided by seconds, we learned that that's watts. So because this is a unit of energy we don't really understand that well, I'm just going to convert it to horsepower. Okay, so I just googled it real quick, and then we got this number right here. And then so I got that number, and that's basically just this number of watts in horsepower. And then to figure out what it meant, I just kind of rewrote it like this. So it's kind of like saying our mousetrap spring, or the average power in it, is equivalent to 3.9 over 10,000. So like a really small number of a horse. Like, I mean, of what a horse's energy would be. And I kind of looked up what horsepower meant, because I was trying to explain it better, but honestly their explanations are really bad. So at least the ones I quickly read. So yeah, I think what horsepower means, if we look at the way we even talked about it in our example, you rewrote it as a fraction, and that's like the amount of energy that this has compared to a horse. So it's this, in this example case that Cameron was looking at too, it would be 7 over 100 thousandths. 7 100,000ths. So I got about, where is it, 4 10,000ths of a horse was how much our mousetrap had.